In the normal operation of the program, we would recommend you record long sequences of vehicle test data. The program has the ability to then display these sequences and cut out the sections of interest. The sections can be cut out according to the velocity or the frames, which is effectively time. So we'll load a raw data file which was recorded, and this is IMU for 1008, and we zoom in to have a look at this profile. You can see there's some cyan at the bottom edge of the screen, which indicates the vehicle was stationary or travelling at very low speed. It's then done a 180-degree turn to position itself for the test run, and then it's accelerated towards the top of the screen and then perform the braking manoeuvre and come to a standstill. So if we now look at this profile in terms of velocity, what we can see is a long period of zero velocity where the vehicle was stationary, and then a small acceleration, and then back to zero, and then it commences the actual profile of the braking test. So a lot of this information is unnecessary, so what we want to do is cut out the braking profile according to the velocity chart. So what we first do is work out a frame position where the test starts, so that will be about that point, and that gives us 29.1 seconds from when the data was started, which is effectively 291 frames, because there are 10 frames per second. We pull the chart extract section, we set start, and that picks up automatically the position of the cyan line. So we set a start position. We then move the chart so we can get back at it in a few minutes. We then move to the end of the profile, which will be about there, 4:31, 43.1 seconds. We then set end, and we've defined the start and end points of the segment of the test data we want to record or save to a separate file. We save that path. We can call this test2, and we save that profile. That gives us confirmation of where the file came from, where it was saved to, and the start and end times. So we say OK to that. We close that. We can now close the velocity chart. Just by way of explanation, if we now look at the acceleration chart, we can see the acceleration profiles, and this confirms that the vehicle was stationary for a period of time because the accelerations were effectively zero. The red and the magenta are not on the zero line, and this indicates we need to apply calibration because there was an offset probably due to the sensor box recording the information not being exactly horizontal on the vehicle. So this is one way to confirm what the offsets need to be, by using this straight segment of data, and then for the testing we need to then just extract the section of interest to us. So if we close that, we reset the display and clear it out. We can now go and load the file we've just saved called test2. We accept that. We now have the profile between the start and end points we set, and we can then look at the velocity chart, and that now has the information for just that profile, the section we're interested in. We do a quick check and find out that it peaked at just under 80 kilometers an hour, so this will be an 80 kilometer an hour run. We close that, and then we look at the acceleration chart, and we now have the profile, particularly the GX is the one we're interested in, displaying the braking test. Again, I remind you that there is an apparent offset, so we now have to go back, apply an appropriate offset to the accelerometer channel, and then we will get a usable braking profile. Also note that we pick up a maximum deceleration of over 1G, but once the chart has had the offset calibration applied, that will come down to just under 1G, which is a more reasonable value.